Welcome to the deep dive. We've got a mountain of research here on multi-LLM agent systems.
MLAS.
MLAS, right? Yeah. Cutting edge and, to be honest, pretty overwhelming. But that's why we're here to unpack it all.
You know what I find exciting about MLAS is it's not just making AI smarter, it's changing how AI solves problems. AI agents that work together learn from each other, specialize.
Yeah, that's a key point. The research mentions using MLAS to manage complex supply chains, optimize financial portfolios, accelerate scientific discovery. That's a whole other level compared to asking a chatbot for dinner ideas.
Oh, absolutely. The scale of problems that MLAS can tackle is unprecedented. Imagine a team of AI agents designing a new drug. One analyzes protein structures, another simulates interactions, another predicts side effects.
Okay, so instead of one super AI, we have specialized agents working together.
Yeah.
But why is that so much more powerful? Is it just dividing the work?
It's more nuanced than that. MLAS offers advantages beyond task division. Think about it. Traditional AI, all the data flows through a single point. With MLAS, we distribute processing and decision-making, making the system more robust and secure.
Ah, so if one agent fails or gets compromised, the whole system doesn't crash. Makes sense for reliability. The notes also mention data privacy. How does that work?
In a decentralized MLAS, each agent operates independently, only accessing the data it needs for its task, limiting exposure and risk. The music service case study you sent is a perfect example.
Right, they started with a centralized model, then shifted to a decentralized star architecture to boost privacy. So instead of all data through a central hub, it's handled by specialized agents.
Precisely. And this decentralized approach goes beyond privacy. It opens opportunities for new business models like agent-as-a-service platforms. Businesses could rent specialized AI agents on demand.
So instead of buying software, you're renting AI expertise. Fascinating concept. But if these agents are all working independently, how do they communicate and coordinate?
Okay, think of it like this. If you had a team of experts solving a problem, you wouldn't just throw them in a room and expect magic. You'd need communication protocols, workflows, ways to track progress and rewards.
So how do we apply that to AI agents? Do they have AI meetings and performance reviews?
Not meetings and reviews, but we need robust protocols to govern interaction. These protocols determine how agents interpret instructions, exchange messages, reach consensus, and learn from shared experiences.
The research mentions a 5-component framework. Can you walk us through that?
Sure. The first is instruction processing, ensuring each agent understands its task. Then there's message exchange, facilitating communication between agents.
So establishing a common language for the AI agents.
Yeah, a good analogy. Then consensus formation. Crucial when agents need to agree on a course of action, especially with conflicting information or priorities.
Sounds tricky. How do you get AI agents to agree?
It involves algorithms allowing agents to negotiate, weigh perspectives, and reach a decision benefiting the overall objective. It's an active research area.
What are the other 2 components?
We have credit allocation determining how rewards are distributed based on contribution, essential for incentivizing cooperation and fairness.
And the last one.
Experience management, enabling agents to learn from interactions and improve over time. Think of it as building a collective memory for the MLAS so it gets smarter.
This all sounds so complex. How do we even begin training these AI agents to work together effectively?
2 main approaches: tuning-free and parameter tuning. Tuning-free optimizes how agents use existing knowledge without altering their models. Prompt engineering, for example, is like giving a chef a detailed recipe.
And parameter tuning?
Parameter tuning modifies the agent's internal workings to refine its behavior, like fine-tuning an engine.
So tuning free is quicker and easier, but parameter tuning offers more control.
Exactly. The choice depends on the task and the desired level of control.
Okay, so we've covered how these agents work together, communicate, and learn. But let's be honest, there's always a flip side. What are the potential dangers of MLAS? What are the security risks that keep you up at night?
That's critical. MLAS introduces unique security challenges beyond typical AI vulnerabilities. We're talking systems of multiple agents, each with its own weaknesses, all interconnected, exchanging information.
So a hacker could target not just one AI, but the entire system.
Exactly. Imagine injecting malicious commands into the MLAS, causing agents to do unintended actions, or corrupting the knowledge bases, poisoning their information.
So not just data breaches, but disrupting entire systems.
A valid concern. And then there's model extraction, stealing the AI models themselves, accessing the MLAS's core intellectual property.
I'm nervous. But there must be ways to protect these systems, right? What's new in MLAS security?
Researchers are working on defenses. One promising approach is input sanitization, clearing incoming data to prevent malicious code injection, like a filter removing harmful substances.
Makes sense. What about those prompt injection attacks where hackers trick agents into executing harmful commands?
Researchers are exploring perplexity-based filtering, analyzing language patterns to identify potentially malicious prompts.
So if the prompt sounds off, it raises a red flag.
Exactly. And there's adversarially robust fine-tuning training agents to resist manipulation. Think of it as mental exercises to strengthen defenses against deception.
So MLAS security needs a multi-layered approach.
Absolutely. Secure individual agents, their communication, and the system architecture to make it resilient.
Reassuring. But let's be realistic. All this tech isn't cheap. How can MLAS make money? We touched on agent as a service, but are there other business models?
There's traffic monetization. Imagine an MLAS managing an online marketplace. As users interact with agents, the system analyzes behavior to deliver targeted advertising.
So optimizing user interactions to generate revenue like websites with ads.
Precisely. But it's not just about profit. We need fairness in how revenue is distributed among the agents.
Right, you can't exploit the AI workforce. How do you ensure fair compensation for these digital workers?
Researchers are exploring blockchain-based smart contracts and performance-based scoring to guarantee fair rewards for contributions.
Interesting. The notes mention a decentralized travel booking system as a good example of MLAS monetization. Can you elaborate?
Imagine booking a trip. You interact with the MLAS, and specialized agents handle different parts. Flights, hotels, transportation attractions.
So like a team of AI travel agents working together for a personalized experience.
Exactly. As you interact, the system can present targeted ads for travel insurance luggage, local tours generating revenue through clicks or bookings.
And those specialized agents themselves could be licensed as a service right. A travel agency can use those powerful search capabilities without building them.
You got it. That's MLAS, creating interconnected business ecosystems, driving innovation and efficiency across industries.
But with all this data between agents, how do we protect privacy? We talked about decentralized architectures. Are there other safeguards?
Privacy is key, and it's multifaceted in MLAS. We need solutions beyond securing data itself. We need to prevent sensitive info leaking through agent interaction.
So protecting data and preventing leaks through AI conversations.
Precisely. Think about privacy at multiple levels: semantic agent interaction and system architecture.
What technologies are being developed for these privacy concerns?
Researchers are exploring options. One is homomorphic encryption, allowing computations on encrypted data without decrypting it. Like working on a puzzle with gloves, you manipulate pieces without touching them.
Great analogy. What else?
Another is secure multi-party computation, enabling multiple parties, in this case agents, to compute a function without revealing individual inputs.
So they collaborate without spilling the beans on their private data.
Exactly. Crucial for building trust in MLAS and ensuring responsible development.
Wow, we've covered a lot in this first part of our deep dive into MLAS. From how agents work together to security risks, monetization strategies, it's clear MLAS can revolutionize how we solve problems and do business.
Absolutely. But remember, with great power comes great responsibility. As these systems get more sophisticated and integrated, we need to be mindful of the ethical implications and ensure MLAS is used for good.
Great point, and a perfect segue to our next segment. We'll delve deeper into specific MLAS use cases and its impact across different industries. Stay tuned. Welcome back to the deep dive. Last time we got into the nitty-gritty of MLAS, how these AI agents team up, communicate, even make money. Now let's see how MLAS is playing out in the real world. The research you sent shows some really cool applications.
It's amazing how many different areas MLAS is popping up in: healthcare, finance, manufacturing, even creative fields like music and art.
The research mentioned a project using MLAS for faster drug discovery. Sounds like sci-fi. How does that even work?
Picture a bunch of AI agents all working to find promising drug candidates. One might scan scientific papers, another simulates how molecules interact, another predicts side effects. Working together, they can go through tons of data and find patterns humans might miss.
So like an army of AI scientists working 24/7. That could totally change the game for pharmaceuticals. What about other fields? Any other examples of MLAS in action?
In finance, MLAS is managing investment portfolios, assessing risk-spotting fraud. Imagine an MLAS tracking market trends, analyzing company data, and tweaking investments in real time to get the best returns.
Like having an AI financial advisor always optimizing your portfolio. That's wild. But there must be challenges using MLAS in such complex fields. What are some roadblocks researchers are hitting?
One big one is making sure these AI agents are reliable and trustworthy. We're talking about systems making decisions with huge financial or even life or death consequences.
Right. How do you trust a system that's basically a black box?
Explainability is key. We need to know how these agents reach their decisions, especially when the stakes are high. This means developing ways to visualize their behavior, track their reasoning, and spot potential biases or mistakes.
Makes sense. If you don't know how the AI got there, it's hard to trust its judgment. What other challenges are there in developing and deploying MLAS?
Scalability is another hurdle. As these systems get more complex with tons of agents managing their interactions and keeping communication flowing gets tough.
Sounds like a logistical nightmare. How are researchers tackling that?
They're coming up with new architectures and communication protocols specifically for large-scale MLAS. They're also using cloud computing and decentralized platforms to spread out the workload and make it more scalable.
So finding ways to manage these massive AI teams. But let's not forget the human side. How does MLAS affect the workforce? Are robots coming for our jobs?
That's a worry a lot of people have, but I see MLAS as more of a team effort than a job killer. Instead of replacing us, it can help us do more automate boring tasks and free up time for creative and strategic thinking.
So humans and AI working side by side, each doing what they're best at.
Exactly. Imagine a doctor using MLAS to help diagnose and plan treatments so they can spend more time caring for patients, or a financial analyst using MLAS to make reports and analyze data, leaving them more time for big decisions and client relationships.
That's way more optimistic than the whole robots are taking over thing. But even with those potential benefits, we can't ignore the ethical side. What are some of the ethical challenges with MLAS?
A big one is making sure these systems are fair and don't discriminate. We have to watch out for bias in the AI agents, whether it's intentional or not, and make sure MLAS is used ethically and responsibly.
Right. It's not just about the tech, but how it's used and the impact on society. Good point. We've talked about the potential upsides and downsides of MLAS, but I'm curious about your take. What gets you excited about the future of MLAS?
What gets me fired up is the potential for MLAS to solve problems we thought were impossible. Personalized medicine fighting climate change, exploring the universe, MLAS could help us take on challenges that need a level of intelligence and teamwork we just don't have on our own.
That's a powerful vision, but with that much potential, we have to be careful. What are some concerns you have about the future of MLAS?
One thing is making sure MLAS stays aligned with human values and goals. As these systems get more independent and powerful, we have to have ways to control them and avoid unintended consequences.
Right. Make sure AI serves us, not the other way around. That brings up another question. What can we do as individuals and as a society to shape the future of MLAS?
We need to talk openly and honestly about the ethical, societal, and economic impacts of this tech. We need to demand transparency and accountability from those developing and using MLAS. And we need to educate ourselves and future generations about the power and the risks of this game-changing technology.
Excellent points. It's clear MLAS is a powerful tool that can change our world, but it's on us to make sure those changes are for the better. In our last segment, we'll look at specific steps we can take to encourage the responsible development and use of MLAS. Stay tuned. Welcome back to the Deep Dive. We've dug into how MLAS works, its real-world uses, and the good and bad that comes with it. Now, in this last part, let's talk about the future. How can we make sure MLAS is developed and used responsibly?
Well, I think transparency is a good place to start. We need to know how these AI agents are making decisions, especially when those decisions have big impacts.
Right. No more black boxes. We got to understand the AI's thought process. But is transparency enough?
Not really. It's more like a first step. We need accountability, too. If an MLAS screws up or causes harm, there needs to be a way to figure out who's responsible and make things right.
So we need clear lines of responsibility, like we have for people's actions. But how do you hold an AI agent accountable? You can't send it to AI jail, right?
That's where things get complicated. We need laws and ethical rules that deal with AI accountability, maybe create new regulatory groups or change existing laws to include AI systems.
Sounds like we're in uncharted territory legally and ethically.
Yeah.
What can everyday people do to help shape these discussions?
Public engagement is huge. We need people who understand the potential and the risks of MLAS, who can join the debate and demand responsible development from those in charge.
So give people a voice in the future of AI, not just make them deal with the consequences. What about education? How do we prepare future generations for a world full of AI?
AI literacy needs to be part of education from grade school to college. Students need to know how AI works and also the ethical and social side of it.
Right? It's not just about coding, but about thinking critically about ethics and the human impact of AI. Important point. Are there any groups out there working to promote responsible AI?
Definitely. Organizations like the Partnership on AI, the AI Now Institute, and the Future of Life Institute are doing great work. They're bringing together researchers, policymakers, and industry leaders to make ethical guidelines, do research, and push for responsible AI.
So there are people on the case. That's good to know. But it feels like we're just getting started. What do you see as the biggest hurdles for responsible MLAS development?
I think one of the toughest things is balancing innovation and regulation. We want to encourage good AI tech, but we also have to make sure it's used ethically and doesn't put society at risk.
That's a tough line to walk.
Mhm.
Too many rules could stifle progress, but too few could lead to problems down the road. Seems like we need constant dialogue and collaboration.
Absolutely. We need open and honest conversations between researchers, policymakers, industry folks, and the public. Share what we know, address concerns, and work together to create a future where MLAS makes life better for everyone.
That's a great note to wrap up on. We've covered a ton of ground in this deep dive into MLAS. We've learned how these AI agents work their potential, uses the risks and rewards, and the steps we can take to do it right.
I hope this deep dive has given you a better grasp on this game-changing tech and encouraged you to play a role in shaping its future.
Thanks for joining us on the deep dive. We'll keep exploring the frontiers of knowledge and bring you thought-provoking discussions about the tech that's changing our world. Until next time, keep learning, keep questioning, and keep pushing for a future where AI benefits us all and